Hello. Let's see. Things are not working. Hello, welcome to a weekly live stream. This will be like a quick one, because reasons. So let's go ahead and get started. Yeah. So those are the patrons. Yeah, tax time. It's really nice to see that the company breaks even. So yeah, like our heat is out here at the moment, so like we're kind of a little bit freezing, and I ate something that didn't agree with me yesterday, and so I'm trying to keep the live stream short because I'm having like a super productive coding day, and it's not the kind of coding I can do while talking about it. But so I took a bunch of notes because I want to make sure to cover where we were. Like earlier in the week, I was wrapping up some changes to the goal-oriented action planning library, and I was trying to take the scenarios to the next level, and was coming up with more limitations, and it wasn't really fitting in the glue that I thought it would. Excuse me. So if we want to think of like all of handling NPC stuff as a big bubble, NPC management as a big giant bubble, and how do I move this now? Like that. Then like we started out kind of with a little section here which was sort of the hacked in, let's see, we had like steering, basic and movement animation. Oh wow, that's not gonna fly. Basic movement animation, basic physics, force, drivers, etc. Right? We had the basic ones that were good for prototypes, and kind of we got pretty far with that, and then later I actually as part of that even we had like prototyped sort of a hybrid of we had like signals. We had the brain, right? The brain had signals. Oh boy, it's stupid. Anyway, signals, signal handlers, behaviors, spelled it the British way, etc. And that worked really good for simple behaviors. And then we got into the town management, which gave us the scheduling API, which I sort of felt like would be the sort of some kind of clarifier as to where the glue needed to be to like actually have smarts in here. And then what I thought was going to be sort of, this is what I thought. I thought the big joiner here was going to be something at least significantly based on GOP, right? Unfortunately, like as I got into it, and I'll kind of try to explain why, I realized that the GOP layer is more like another little utility, kind of over here somewhere, right? Actually, probably closer to, whatever. It doesn't really matter where I put it, but it's not the glue. It doesn't. We still need signals. We still need signal handlers. At least I believe so. And so I still lacked the glue, and I'll get into a little bit about why. I'm trying to think how best to describe it. I was just going to kind of wing this off the cuff, but maybe I should type stuff up as I go, so it's like a little clearer. So let's make a new page. AI progress recap. So let's talk about. I'll just like type up some notes as I go. So yeah, we started with. Yeah, I've got like my notes here. So yeah, we started with the that signal behavior stuff. I couldn't really decide whether I wanted to do behavior trees or finite state machine. Behavior trees or FSM, finite state machine, or something else. Each fits a different problem better than another. Each fits different problems better than another. Almost all of them can be expressed in a different form. Example, behavior trees can be an FSM, vice versa. And it's just that certain constructs fit certain cases better. And so I was doing like a hybrid approach where, like, at the root, you could kind of think of it as a finite state machine where we had signals and signal handlers that would take us to different states, which would load in different sort of behavior trees, although they were always really simple. I actually find behavior trees are easier to understand when they're simple. You could have a behavior tree that gets quite deep and can handle your whole UI, where you have like a root selector which can select all these things. Do I chase the bad guy? Do I search all the rooms in the building? Do I eat something? You can have like all of these things, and each one of these can be extremely deep in the choices that it can make, and so on and so forth. And in the end, it's no more simple or complicated than the GOP layers. It's just sometimes hard to read when you get down there and you've got like these deep trees that go super far down. And really, at the root, it almost resembles a finite state machine, because you have some kind of decision. You have some kind of decision that happens to decide which branch to take, and they're usually like ordered in a priority and so on and so forth. So is this any better than having simpler behavior trees and then a finite state machine that controls those? We could argue that. Similarly, these could be all expressed as GOP rules if you want to carry your world state far enough to the point where you could really sort of pathfind through all of those GOP rules to find the same sort of set of actions you would perform. So anyway, I believe that probably if you sat and did the math, you could figure out that any of these approaches could be expressed in the form of the other one. And so that makes it deceptive when you head down a path that that seems to be working, and then you hit some sort of specific dissonance that, this would work, but now it's actually becoming difficult. I'm having to build out 500 layers of rules where, and this is the other thing, where a single code block would have been fine. A single if else would have been fine. But to do the same thing, because it's got pathfinding and stuff built into there, I'm having to build giant rule trees. The behavior tree, for example, if you wanted to write a behavior tree to search all the rooms of a building, presumably all of the rooms of the building. That behavior tree could be quite deep, whereas the code to do it could be like one loop that iterates over several different behaviors. So it just becomes a problem of what do you express, how do you express your sort of knowledge or rules, and so on and so forth. And of course, Mythruna has its own interesting constraints. Mythruna's specific hurdles. Let's see, what is it? Specific hurdles. Specific. Is that not how you spell specific? It is. It just doesn't like the Mythruna part. Okay, so rules, hurdles. Infinite world. We keep bringing that up, but so it's got an infinite world. 10,000 NPCs is different than managing 100. Whoa, that was fun. Manage, I'll spell it out. There's the idea that the world isn't known ahead of time. The world isn't known ahead of time. Like you don't have a static world to build from. Not only is it randomly generated, so everyone is different, but you, the player, can blow up entire towns or whatever, and it just, so the world isn't known ahead of time. The AI has to adapt. So what I put down in here is it's more of a Dwarf Fortress problem than a Skyrim problem, for example. So like the problems that would come up in something like Skyrim, and but this is the kind of AI we want, right? We want more of an AI, like a Skyrim type of AI, but we're working in like a massive scale and more of a Dwarf Fortress style problem. So anyway, a lot of the stock solutions don't fit, and so that's why I struggle. I don't have I can't just go ask AI what to do because it doesn't give me good answers. So let's see. Yeah, so we started with we had the signal behavior. This stuff. We had the signal behavior signal handlers behaviors. But even with that, I knew that there was some kind of abstraction I was missing, and I put in too many abstraction layers. Like the signal would create goals, and the goals would find goal handlers, and the goal handlers would create reactions, and the reactions would have behaviors in them. And there was just I couldn't decide where I wanted the abstraction to be for, a duck navigating is different than a human navigating. If one of them is going to be dumber than the other, right? So there's some strategy that's different. And I couldn't just really decide. So I, simplify all that. That's fine. So we have the hard-coded limited motion drivers. We had a really reasonably fleshed out steering layer, though. We were able to reuse that in the demo last week, and it's fine. I think we've learned a lot about probes, and steering avoidance and stuff. We did a lot of prototyping with that. We did a lot of prototyping with sort of basic nav meshes. In fact, I used that to sort of back into this architecture that we're going to talk about in a second. So and again, the scheduling layer, I think this is pretty well fleshed out. I loved watching the NPCs walk around, and I think that's pretty well fleshed out. It just, the rest of it needs to be turned into code, though it's 60% of it's already Java code, and the rest is still in the Groovy prototype. But yeah, so I originally thought Gope would help fill the center, but and it's come quite far as a library. It is in some ways more advanced than any of the other Gope libraries I looked at, because its understanding of world state and its ability to build temporary world states that reference the previous world state and so on is quite advanced. And I was even able to build locations and started to add costs in. So that's another thing I'm missing that I didn't include in my notes. The idea that it takes longer to walk a far distance than a short distance, and so that should be factored into the decision making. Put a pin in that because this is back to nav trees, by the way. And so it's quite far. It's only missing a couple things before I would call it quote unquote done. I mean, it needs to be bulletproofed and things, and documented, but I'm actually quite impressed with how well it can do even unoptimized. So we will definitely use it. And I actually think it has a lot of play at the sort of town strategy level, because when you really have, if you were going to implement a behavior tree and it's going to be 500 layers deep, it is probably easier to express that as a set of goal-oriented action planning rules. It can strategize a little bit better when it has a lot of decisions to make. It can explore that decision tree better than you could decomposing into a giant static behavior tree. It could create a dynamic one, right? It may take it a while, but it's going to be able to reason about what's going on possibly better than a human could to build this out. And if you define your rules in a very specific way, it could do it quickly, relatively speaking. But I just think that on some level it's easier to reason about, if I want to create a dagger, I have to be standing at the anvil and I have to be banging on a hot rod and so on and so forth, and the backward chain from that than it is to, try to create a behavior tree for all. And that's a bad example because it's just easier to code. But so it's only missing a few things, but again, it turns out to be probably a smaller piece of the architecture. Yeah, the thing I had trouble with GOP is that backward chaining is really hard to reason about. It makes a lot of sense logically, right? I guess backward chaining, and this came from expert systems, right? Backward chaining originally, I guess, came from like the moon landings, where you have the Earth, that's like a continent. Pretend that's a continent, and you got your moon over here, and when you launch a rocket ship from the Earth, you have like literally anywhere you can go, but you want to be on the moon here at such and such a time. And so you can decide, well, if I need to be at the moon here, I need to enter I need to deorbit here to get there, which means I need to be in the orbit here to get here, and then you can backward chain, to figure out where you need to be to get there, and that considerably lowers. If you're trying to do it, assuming you don't have infinite fuel, right, and you just can't go there and land wherever you want, you're trying to minimize the cost, and so you backward chain, and eventually you figure out, how you have to launch, what day you have to launch, when you launch, in what direction, and so on and so forth, to get to that spot on the moon, because you backed it up, right? You knew where you wanted to be, and you figured it out. And so there's a lot to that, but it's very hard to reason with, and if you're searching the entire rule space, and trust me, because when it didn't do what it was supposed to do and I had to debug it, it was like hours of going through logs. And even in the simple case of, we wanted to create a dagger. In order to create a dagger, we had to, go get the hammer. We had to go get the rod. We had to put the rod in the forge. These things were very simple rules. Let me back up here. So in order to create the dagger, we needed a hammer equipped. We needed a rod equipped that's hot, right? And we needed to be at the anvil. And then in order to have the hammer equipped, you had to be at a certain chest, and then you could pick it up. If you wanted to have the hot rod, you needed to be at the chest to get the rod, and you needed to have the thing heated up, which means you had to go to the anvil. Anyway, so on and so forth. But so as it tried to figure out what actions to do, it's traversing these backwards, right? It doesn't know anything yet. It's going backwards. It says, well, I know if I do this, I have to do this. Oh, I can't do that yet. I have to do this. And then once it figures something out, it can start going forward and say, now I know stuff. I can go forward and I can come here. Oh, now I still need something else, and it can go. And so it eventually, explores all these, and it does it in like every order, because it doesn't know which order is going to be optimal. It's exploring all these spaces, and because it's not like a physical space where you can see something move around like in our demos, it's extremely hard to keep track of, when I'm at this node, am I at this node just because I just came from here, or am I at this node because I traversed all these other ones and now I'm here? And so you've got like different states. Anyway, trust me, it's complicated, and I actually have some really good debugging tools available now to track this down. And so I've shortened my 2-hour, trek into the rule disassembly into 15 minutes sometimes. But the point is, it's really hard to understand. And there's sort of a fundamental problem with this in that we're dealing with things spatially as well as conceptually. And so I think from a strategy perspective, this is going to be pretty good, because there's no spatial coordinate. Let's see, I've been playing with Oblivion. Yeah. Actually, the Oblivion AI in many ways is more advanced than the Skyrim AI, right? Because the NPCs there all have schedules. Now, they're pretty dumb. Like, there's all kinds of videos about, like, you talk to a guy and he'll tell you all about something, and then you just immediately hear him passing somebody on the street, and they'll like, hey, did you hear about that thing you were just talking about with that person? Did you hear about that topic? The same topic you guys had just been talking about. No, I haven't heard. What's that about? And it's like, oh God, dude. Anyway, so again, like, you want a system that makes the NPCs look smart, and so occasionally you see behind the curtain and you go, okay, well, they're not as smart as they think they are, or whatever. But so yeah, backward chaining is hard to reason about. They say that is the limitation of GOP, and I will 100% guarantee that, yeah, for any non-simple rule set, it can be really hard to reason about what's going on when it's not doing what it's supposed to. And then this is sort of touches on a point in the thing I stuck a pin in before. a certain amount of, a significant amount of AI thinking is pathfinding, right? Even within here, we had to be at the anvil, or we had to be at the forge, we had to be at the chest. So like, there was a physical pathfinding, and most of the struggle this rule set is going to have is going to be based on those physical motions through paths. And so it was very tempting, like, can we integrate spatial pathfinding into the GOP rules? And this is the last week or so, I've spent a couple, I've spent a couple different approaches trying to do this, right? So there's one approach where, instead of just, am I at the anvil? Do I have a path to the anvil, right? And then you have some kind of iterative approach, because that's the other thing, is you want to try to keep your solvers iterative. That's one thing I learned about in the last 5 or 6 years as we've been working on this problem, is it's not a smart AI. It's okay. So like, if you have a smart AI and you ask it a question, hey, these are my goals, what should I do? And it comes back with a great answer. That great answer is not useful if it took it 5 minutes to come up with, right? I would rather have partial answers quickly. I would rather have something that didn't hang for 5 minutes while it did it. If it took it 5 minutes, but the rest of the game could keep running, that's another thing. And not I'm just talking about spinning up threads. I'm talking about being able to monitor it and decide we don't want to do it anymore. And so if you want to have algorithms that you can slice through time, you can slice up. And so GOP was very good at that. Navigation paths are very good at that. You know which paths you haven't checked yet. You can check the next one next time you hit through. And so these things are very similar. But like, if this rule required that you have a path to the anvil, then was there some way I could keep calling this without actually what I call a particular position in the state tree is a proposal. Like, if we're here and we've been through all these nodes and we've collected this state and we know we're here and we're going to keep going, that is a proposal. We know some set of actions that got us here, and we're still trying to figure out what actions get us back to where we want to be. And so that's a proposal. We have actions, we have things we haven't tried yet. And so, like, where was I going with that? So can we iterate on a proposal? Like, right now, proposal is just a node in sort of, if you want to think about spatial pathfinding, it's a position in space, right? But can we say at that position, I don't want to branch yet. I don't want to try the other branches. I just want to keep iterating on this because I have one of my conditions is an iterative condition. And so I designed that in, and I was ready to start implementing it. But it occurred to me that's not really the problem, as there also is the issue of sort of relationships. We had kind of like hacked in this sort of at state, where you're at an object, but you can only be at one object at a time, even though in the world you can actually be at multiple objects at a time. And so when I turned that to locations, I realized it's another problem. You can reason pretty well, and I was able to write all the rules that if you were going to be at the anvil, and the NPC is specifically standing on the same location as that anvil, because for pathfinding and stuff, not for pathfinding, for rule resolution, for plan resolution, that was good enough, recognizing that the world was going to keep me from standing right on that anvil, but it's disambiguous, right? But again, so like, and so building pathfinding, and the fundamental issue is pathfinding, like in space, makes a lot of sense going forward. You can do it backwards, but you have to already know where you're going, like specifically, and that may not be something ahead of time. And so working backwards doesn't always work great for pathfinding. So I'll talk to you in a minute about the example I used to like have this all fall apart. So before I launched into any of this, I was like, well, let me break down, because the other thing is I kept coming back to some of this is just easier to write in code, and we could get, like, I had fully planned to start like this week getting ready for a live stream tonight where like we just ignored Gope for a little while, and we would submit like, these are the goals I want to create, and we would just hard code some code to just generate some action lists, because we could work out a whole bunch of other stuff if we did that, since we had defined sort of the action queue last week. And it occurred to me that there's a lot of these that it's just easier to write actions. Like, why am I doing all of this Gope processing where it is actually easier for me to say, oh, you want to create a dagger? Well, first you're going to have to gather these materials. What's the best way to do that? And once you have all the materials, you go stand in front of the anvil and you do it. The code is so much easier to write than the rules were to construct, than the rules were to debug, and it all came back down to pathfinding. The other thing about general pathfinding, spatial pathfinding, is that it's not like you start, so let's say somewhere around here I have like a little town and stuff, but normal pathfinding, you start here and you think of it, I want to get here, right? And so then it figures out, it tries all of the different paths until it eventually finds the one that gets you there, right? But it doesn't have to be that way. You can actually say, we're starting here. We're going to check all of the paths, but we only need to satisfy some condition. It doesn't necessarily need to be, I want to be standing here. It could be, I can see here, or maybe I want to be standing at one of these places. Like, any one, whichever one I get to first is good, right? And with normal pathfinding, that's fine. Like, if I did the iterative Gope thing that I was talking about, each of these X's would have been a different pathfinder. So like the whole infrastructure in order to build the paths and check them out and all that other stuff would have been independent of one another. So for 1, 2, 3, 4, 5, we would have had 5 separate path solvers. And that's just a waste when a single path solver, if you want to just find the best one, it can do that. It can check every position that it goes for any number of conditions that you want. And they could be optional, right? Like, maybe it's okay to see this one, but you have to be at this one, and so on and so forth. And it can solve for that and just find the quickest path to get to one of those, right? You have a lot of flexibility there. And so that, so the scenario I came up with, because I basically had all these scenarios written from when I was doing the town AI, and I was just trying to define initially like what sort of sensors we would need, like sensors and triggers and signals and things. And it was funny because I had broken an NPC's day out, all the different things, because I was trying to figure out what the brain code would need. And it was funny because the very first one made all my stuff fall apart. And that was an NPC sleeping in his bed. But he hears a noise. Is the noise in the house? Is the noise outside? Does he have to get dressed first? Does he lock his bedroom door? Does he lock his front door? Does he have to get the keys from the nightstand? Did somebody in the night come and steal his keys from his nightstand, so now he's stuck in his room? This is just complicated stuff, but it's all quintessentially based around sort of iterative approaches based on pathfinding. His path to the door, his path to outside, does he climb out the window? These kind of things. It's all like tightly coupled into that navigation tree. And so, that's when I started thinking about it differently. Yeah, so like, let me see. Let me just make sure in my notes I covered everything. So yeah, we'll take some ideas of Gope and use them in a live, forward-thinking architecture that's sort of based on, pathfinding. So, and no, not based on pathfinding, but based on sort of a slice architecture. We're going to iterate over design. So what we end up with is, so new approach, new architecture. I can't type now. I've been talking too much. So you have like these, what I call them strategizers, but I may change this to solvers. So a strategizer would come up with a strategy, right? And so the main thing on a strategizer is that, so you have a bunch of pending strategizers, one active one that we're thinking about. And so every frame we can think a little. And eventually, so with step, 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 and eventually we'll get a strategy out of that. And the strategy could be, oh, by the way, there's this other strategizer we have to do. Or the strategy could be, oh, here's a list of actions to perform. Or a strategy could be both of those things. If you think of the example of that NPC, he hears a noise outside. And so he wants to run outside and see what it is because he can't see it from his window or whatever. We've pathfound enough to decide, okay, he can't see it from his bedroom window. He's going to have to go outside. He's got to get the key from his nightstand to unlock the door, and so on and so forth. And anyway, but for whatever reason, we figure out that like the key is not there, but he's still going to walk to the door, like to see if it's unlocked and stuff. So instead of just returning a strategy or a set of actions, we return a new strategizer and a set of actions. So we continue the actions of him going to the nightstand and trying to pick up his key and go to the door. He's going to fail. In the meantime, we can be thinking about, well, what's his next strategy going to be? Because this is a realistic way for an NPC to behave, right? He didn't know laying his bed. He's not omniscient. He can't tell that there's nothing in that drawer from where he is. He's got to actually go and do those things. This is the other problem with GOP is any time you're doing backward chaining, if you decide you've failed, like you can't solve it, you've got essentially no useful information to run from. If you're forward chaining, if you go to your navigation path, even if you can't find a destination, you have a whole bunch of paths you tried, and you can start on a path. You can use that information to get you closer, right? In this case, the door might be locked and we can't get it. We can't get it open, but we can still go to that door and look confused while we think about the next thing. Anyway, so I like this approach. So far, like on paper, it's working out pretty well. So strategizers are kept in a pending queue, and a current strategizer is active at any time. Though that's the thing is we could also, in any of these pending ones that are in a queue, this priority queue, is sorted by priority. We could be thinking about them too, like, every once in a while we could iterate over them and let them iterate, just in case, we're gonna like pull them up later. So pathfinding becomes a core feature because it's very powerful. Exploring an action space is not that different from exploring a physical space, but especially when the locations are the primary driver of the action. And so, which is like 99% of the time, all of my current examples, the spatial component is prime, right? Any of the decisions that the NPC is making, from creating the dagger to pulling a rod from a chest, they're all based on where is this stuff in the world and how do I get there? So building in pathfinding as a fundamental core is sort of important. So I've already talked about this. Pathfinding software can take a lot of conditions into account. Be at a specific location, be looking at a specific location, have visited a specific set of locations. So that's the one I didn't cover, right? If your goal was to visit all of these, you could try all the paths until you found one that was the shortest one that also had you visit every one of these paths. And that could be useful if you need to pick up these 5 items and where you think they are. You could go to this. That was the other thing is, what does the NPC know? In a GOP style rules, it was actually becoming increasingly difficult to implement sort of memory. What does the NPC know? I think it's going to be easier in here. Like when we created this, we wanted to find this path and we knew we had to get these 5 objects. Where do we remember those 5 objects being? And so we'll go check those places until we find out we can't get there or they don't have what we're looking for. So the other thing is, if we're building this in, being smarter about pathfinding integration means we can also build and restructure the navigation cache on the fly. Like in the town example, I had built a navigation graph where like every intersection, so it had like a waypoint, and so rather than cell by cell solve all the paths through the town, they only had to get to a street or an intersection, and then they could navigate the streets themselves. And so building that when I build the town, that's not hard. Having it update automatically when the streets get blown up or when new paths are created, new bridges or whatever, that can be difficult. But if as part of your navigation graph, your waypoint graph traversal, you're also doing, regular cell-by-cell traversal, once you've figured out that, hey, a bunch of paths tried and they all went through this one point because this is a doorway maybe, and so now hey, I can make that a new waypoint because probably a lot of different paths are going to go through there. And so, like, if you keep track of these sort of statistics in your navigation solver, you can potentially pull them out to adjust your waypoint graph, add new waypoints, new paths. Mark old ones as dead, like if a bridge gets burned down or something, that's no longer a good path. And even knowing that that path is no longer good can be something that the town needs to know about so that it rebuilds the bridge or queues up actions to rebuild the bridge. These are all useful things, and so again, like, I'm sort of beating a dead horse at this point, but existing waypoints, existing waypoints and waypoint paths can be pruned. Yeah, and the other thing is, like, when we did our navgraph stuff before, it was based on positions. So, like, if you started at this position and you walked a meter this way, then you'd be at this position. And if you walked a meter this way, then you'd be at this position. The new stuff I have is based on actions. And so if you start at this position, your choices are not new positions. They are walk to this position, step up to this position, and so on. So you get a list of actions that to perform. And so, let me write this down, because, like, navgraph gives action branches instead of location branches. So you get, might walk to location, you might get open and step through door, you might get jump up to ledge, you might get jump across gap, you might get climb ladder. This is like a sort of I did it because of the door stuff, but it actually solves a problem we had before, in that when we were doing our pathfinding stuff before, it would solve the path, but then the NPCs would have trouble walking up the stairs, right? They didn't know that they were supposed to step up, and we had, like, I tried to build that into the the mover part that, like, takes the physical forces, and if it detects that they're at a step, it's supposed to step up. But this sidesteps that completely because it's actually built into the actions. They know that they're supposed to step up. It's not just something they have to guess at based on collisions. And I think this will make smarter looking NPCs. And they'll be able to do more things like climb. And the other thing is, we couldn't have jumped across a gap before to say, that would have been almost impossible to implement. And of course, the open and step through a door. So that's the thing. So the navigation is based on a list of actions. Yeah, nicely solves the walk, jump, fly, climb, leap problem. Yeah, open door, step through there. So I had an example, which probably is easier to just pull up the note than actually I'll just pull up the notes and I'll copy it over. How's that? By the way, if anybody's interested in seeing this note file that I created, the stream of consciousness style, I can post that too. So let's make this a little smaller. And I think it's already console, yeah. So that's fine. We can fit it a little bit. Let me make it a little smaller because I've got this really zoomed in, so it's fine. Yeah, that's a little too small, maybe. So I wrote some pseudocode. Maybe 9 points. Okay, 9 points seems reasonable. I wrote some pseudocode about, like, what does the go to see the noise strategizer look like, right? NPC hears a noise out in the street, wakes him up from his slumber. So that signal comes in. We add this strategizer to the pending queue. It's the highest priority, so it it's higher priority than sleep is, so we do it. And so each step call, we say, we have a path. We have a path solver we're trying to do. If the path is not done yet, well, we iterate on the path, and we return not ready. It means we want to, like, next frame, call us again. If we've finished that and the path is not found, well, then we can return a failure strategy. Either like we do nothing, or we could return another kind of pathfinding strategy, or we could say, come back to this one, but we could return ourselves with but we've added impassable locations. We've reset the path solver and we've added like these places you can't go to because the doors are locked, or we're blocked. Like the thing we thought we could get through, we can't anymore, and so it'll try again, and it will path solve maybe a different way. Or it could be that it gives up and falls back on another strategizer. Maybe instead of going to see what it is, we do something else, or we go back to sleep. Could be that it retries the strategy with new impassable locations. Well, also, yeah, that's the one I've talked about first. Well, it could walk as far as it can at the same time, right? If he expected to be able to walk through his bedroom door and he's going to get blocked by that. Well, we come back to this solver to redo, re-strategize. But in the meantime, we go ahead and walk to the door that's locked. That's what I was talking about before. And so, if the path has other requirements, so we figured out a path and it's successful, but if we iterate through those actions, we realize, there's an open door action that requires that door be unlocked, and that door is locked, so we're going to need the key. Maybe our bedroom door is locked and our front door is locked, so we're going to need 2 keys, and so we can return a new strategizer that does a path find to find those keys. And then when it's done, it comes back to this strategy, because now we could actually perform those paths. And when we come back to this strategy, we're going to be in a different place, so we actually might redo the paths and so on and so forth. Might have a different path find. And so, on success, we return the strategy containing the series of actions necessary to see the noise, which could be, by this point, get up, unlock the door, get dressed, whatever. It could be a bunch of things that we've decided. So anyway, this is easier to think about in code. And actually, that's the thing is when we got the signal in, there was actual code, not some rules, not some behavior tree, not necessarily. It could have been, right? But we had a chance to just write code that says, hey, I'm not dressed, I should get dressed. So let me get dressed, and then I'm going to put this strategizer in to go see the noise, and so on and so forth. We have some flexibility. And so I was starting to prototype what the loop looks like. I have code written that does some of these things. Basically, what I ended up doing was writing a quick and dirty. By the way, this sleeping and waking to see the noise is the scenario I'm going to be working from, and I started writing code and implementing another test. And so see, it's really easy for me to iterate in unit test. With partially things stubbed out. It's just not very live streamable. I just don't think that's very entertaining. But so here is I've defined a bunch of, pretending that there's some kind of navigation graph where there's waypoints. I've defined a bunch of places like his bed, his bedroom, bedroom door, living room, so on and so forth. And then I've created the graph of that. And then I've verified that at least solves. And so now the next thing would be to implement, sort of this strategizer that then uses that pathfinding and makes these decisions. And so that's what I'll be working on tonight and tomorrow. And hopefully I'll have a better answer on how well this architecture ties everything together. It certainly can tie everything together. I'm hesitant to say that this is the solution, because I've felt like the last 5 things I've tried were the solution. And we've learned something from every one of them, but yeah, I think GOP is just a piece now. I think that it will probably live somewhere, maybe even right here, right, as part of the scheduling. Maybe we'll ask it some things. But that's the thing, is one of these solvers, these strategizers, could be, instead of doing pathfinding, it could be asking some GOP rules. Give me, solve these things. Give me, from these conditions, give me a set of actions that I can do. We still have it. So that's why I feel like this is a good glue. It's sort of an iterative iterative behavior tree, if you want to think of it that way, right? It makes very little, thinks about what it's doing before it actually does it, and then sets some actions into place, and then there has to be like failure modes and things. These are the details I'm working out right now. But anyway, that's sort of where we are and why I didn't have anything that I really wanted to show tonight. Plus, I wasn't sure I could talk for 2 hours without having to run to the bathroom. So, although I'm feeling pretty good right now. And it's freezing cold in my house, and I have like the space heater behind me. So anyway, I think that's probably where I'll end it, but I'm gonna like leave it a few beats and think of anything else, if anybody has any questions. Make sure I covered all the stuff on my notes. Yeah, there's still plenty of open questions. I haven't figured out exactly how I want to avoid duplicate strategizers. Like if if something else makes a noise in the street again, how do I avoid adding another go see the noise strategizer? So I have to figure out how I want to key that. And maybe that we do separate goals from strategizers. You need a live stream Snuggie. Yeah, you might be right about that. Yeah, I got this heater behind me that's blowing on me. It keeps me nice and warm. But I have to put a sticky note down on the microwave to tell people if they want to use the microwave, they have to text me first, because I have to turn it off because it's on the same circuit. Even though they're plugged into different sides of the house completely. If somebody tries to run the microwave, it trips the breaker. So the other thing is, plenty of open questions. I'm still getting code written, so I haven't actually tried it yet. I haven't implemented this yet. It could be that there's some peculiarities that make that undesirable. I don't know. Let's see. I'm going to look for questions while I go over my notes real quick, just to make sure I covered everything. Behavior trees, state machines, GOP. None of them a full answer on their own. Sometimes one approach fits better. Yeah, I did that. Backward chaining is hard to reason. Yeah, I did that. Sleeping NPC. I can't believe sleeping NPC turned out to be the tricky one. Take some of the IPs. GOP. Got GOP pretty far. At least talked about the hurdles. NPC bubble. Yeah. I basically have more detail here of what I covered. Scheduling there pretty well fleshed out. Yeah, a whole bunch of things on GOP. Always been missing a critical piece of glue. Yep. Still, I'm hoping this is the glue that puts all this together. Ooh. Yeah, I'm hoping this is the glue that ties all that stuff together. At least I'm writing code, and that always feels good. You spend 3 or 4 days writing these style. Of course, now I'm holding too many things in my hand. But spend several days writing these style note files, and it feels good to actually be getting to the code part again. So anyway, I'm optimistic about this. And I think I covered everything from my notes. So thanks for joining. Apparently we had 6 viewers to see this, so hopefully it was interesting. I never really know how these things will go over, but I am still working really hard on this. I've actually had lots of time. I cut some other things out to really focus on this. Again, I want to stress, this is the game. You could consider everything else, resource management, whether you get hungry, thirsty, and you have to eat stuff. These are all just a spreadsheet. This is super trivial to code. There's nothing intelligent about any of that. The game is going to be this, the AI, right? Hey, happy Saturday, Chuck. So it's important to get this right. And so if we get this to a good state, the rest of the game falls out from here. We plug in a gossip system, knowledge system, all these things, they plug into here. Java for life, yeah. I agree. So that's why I'm spending so much time on it. It's trying to get this right, because the rest of the game falls out of this. This is. If I have to fall back on standard NPC style scripts from something like, was it Neverwinter Nights? It's things I'm familiar with. Standard. I can do that, but I'm trying to come up with something better, because that's sort of what the core game is going to be. Is these NPCs in the towns and how they interact with you, the bandits on the road, et cetera, et cetera. So I feel like it's important to get right, and that's why I've been spending this last few months on this. Anyway, that's all I got. I think, like I said, there's going to be a shorter live stream, but still, I think it was about an hour. Chuck just joined, but happy Saturday, and I think that's it. I'll give it like another beat, 5 seconds or so, to if anybody wants to ask a question. But otherwise, and I didn't even hardly sip my Pepsi. And as said, if anybody wants my raw notes for this live stream in a sort of semi-organized form, I can post those somewhere. No problem. Just hit me up on Discord. All right. How would groups of bandits work? So a group of bandits would be managed like a town in a sense, right? They would have a a group of bandits has its own sort of equilibrium that it has to maintain. It has to keep its people fed. It has to keep them paid and so on and so forth. So at a high level, a group of bandits would have a strategy similar to a town in execution, if not rules. It's obviously its goals are different. But actually the whole town thing, treating towns like their own sort of scheduled entity in the world, solves another problem I have. As I watch, you guys can kind of see it in the background here, but this is the log from the public server. I'm always shelled into Hetzner. And so every morning, any of the spirit portals that the world knows about, it modifies itself, to turn the light on. Yep, even free rovers. That's true. So like I watch these logs, and so every 10 minutes or so, it turns on the spirit portal, and then some minutes later turns it off again, and it's modifying all these things in the world and sending out leaf change events and so on and so forth, because it doesn't know any better. And if I'd had the settlement layer, I could have set this up as a settlement schedule, and since settlements wouldn't be active unless a player is actually seeing them, and if a player sees them, it would hurry up and run whatever schedule it needed to be to set the state at the time. I wouldn't see these anymore, because right now the server's doing work when nobody's logged in, work that nobody will see, and it's doing. If the world is widely explored and all of these, if you got 100 spirit portals active, at dawn and dusk every day, it's going to activate and deactivate these spirit portals when nobody might be seeing them. It's not really. I mean, it's not a threading problem. Threading creates its own issues, right? I don't want to spin up a million threads. I want to manage the work I have. I don't need it done quickly. I need it done low impact. So, if I have a million NPCs, I just need to manage their time slices carefully. You need to prioritize them and manage them carefully. And even virtual threads don't really give me that. But anyway, so like we've already gotten some benefits out of this. When I incorporate the town logic in, I'm going to redo these spirit portals as settlements, that even farms will be like that, right? Like originally I was thinking I'd have to keep track of every seed planted in the world, but I think what's going to happen is as soon as you plant a seed in a particular tile, I'll spin up a local little town to manage whatever other seeds are planted in that area, so that if you're not there, it's not doing work. But if anybody could potentially see that even from 3 tiles away or whatever, then see, we just saw it. It just it just modified a bunch of other cells in the world. So yeah, like even like that solved a lot of problems. So like already we're fleshing out game just by doing this, and so yeah, we'll answer a lot. So it's critical to get it right. That's the bottom line, and that's why I'm spending so much time on it. And it's not doesn't always look really cool, but maybe next Friday I'll have some cool stuff to show. Maybe I'll have a simulation of the NPC sleeping in his bed and hearing a noise outside. We'll see. But if I can apply this to that, and if I can apply this to the original problem of crafting a dagger, I think we'll be pretty well set that this is a decent approach. And I have like a whole scenario set up for a whole NPC day that I could go through. Is your computer pinging notification sounds like a USB drive mounting and unmounting? I'm trying to figure out. No, that doodle doot is the delayed. What I have is an app called Mix It Up that's watching the chat, and it makes a sound whenever a chat comes through, but it's probably as delayed as you guys see it. I see the chat early, and so I'm already answering the question. But if I happen to be looking at this screen and not this screen, then it notifies me that somebody chatted. And roaming trading caravans, absolutely. And like the one example I use though is like the traveling airships. Like an airship of traders, might be a crew. There would be captain, the people who run the airship, and whatever trader, and the cargo people who lift off the cargo, and so on and so forth. That could be a whole 4 or 5 guys that are in this mobile settlement, and so that'll be the tricky part, is implementing mobile settlements. But a caravan would be a mobile settlement basically. So yeah, that's the way. Yep. So you're right. So yeah, we've had good questions. So I'll hang out for a second. Somebody, make sure it's somebody on the general channel here. Somebody joined the Discord. Always nice to see. So yeah, the other thing is, if you aren't a subscriber, let me show you why that would be a good idea. Let me see if I can go to my channel before you guys see my recommendeds. Yeah, so I have 977 subscribers, dangerously close to 1,000 subscribers. So if you're not a subscriber, please consider subscribing. Dangerously close to 1,000 subscribers, which would be kind of cool. How would NPCs work with moving airships? Wouldn't there be physics jitter? So no, because the physics engine already knows about moving things. If you're standing on something with its own velocity, you have a ground velocity, and so your forces and stuff. I mean, there's probably going to be a little sliding. I don't think it's avoidable, but for the most part, the player, the NPCs, they already know they're standing on moving things. So when we get a NPC that's standing on, let's say, a moving barge that's going this way, when we got this contact, we already knew that this was not a world contact. It was the contact for a body. That body has a velocity, and so when we calculate sort of this NPC wants to walk this way or this NPC wants to walk this way, we subtract this velocity from their desired velocity, so that they know how much force to apply to move in that direction relative to what they're moving on. Yeah, nice theory of Newton, something like that. I think I think so far it's working. Again, I don't have any really good examples because none of the current airships move, but originally when I developed a physics engine, I had an airship that would move around, and I could get on it and walk around on the airship, and it was totally fine. If I jumped, it got weird, right? If the airship was moving in this way and I jumped, it would move underneath me after a while, and I would end up back here somewhere. But that's not entirely unrealistic. The tricky part will be when the airship is far enough away that I don't have to manage the individual people, then I need to keep track of the fact that their world positions are relative to their sort of mobile town and move them around with it. So there is some trickiness there, but as far as the physics engine goes, no, it's actually easier on that end than it is on the sort of just town management end, because everybody has a world position and this is relative to the world position. It's funny, I read different approaches that people have to use in other engines. It's illuminating. It's a tricky problem. I agree with that, but moving platforms is something I built in. In fact, yeah, I did that with even JBullet, that the JMonkey engine integration. I have a demo somewhere with the little monkey running around, and he could jump onto platforms. It's the same kind of deal. The platform knew it was moving, and so it like imparted that movement onto the object that's sitting on it, and so on and so forth. All right. Any other questions before I wrap it up? This looks like a planet that's about to blow up or something. Yeah, so hopefully, like, I'll have a lot of this coded by next week, and we can start seeing visuals again. Maybe I want to start getting it in the game. I'm tired of messing with prototypes. Alrighty. Well, thanks for joining, everyone. I think this is my button to say thanks, everybody. Please like, comment, subscribe. Definitely this is a video to comment on. If you have any questions at all, please comment and I will answer them, or join the Discord, which you can get to by downloading the game. There's a link on the splash screen when you start the game to join the Discord, and we can have interactive conversations there. Otherwise, I will see you next time. Thanks, guys.